A very warm welcome to the Maritime Education Podcast. My name is Barry Sadler. Welcome to our latest episode, which today will be talking about a specific type of cargo. As a pilot, I often get the opportunity to talk to captains about the cargo that they are carrying on board their ships. This may be just as a general inquiry as to what the captain's carrying. It may be that the ship has had to go to a specific berth, or in the case of a ship that I piloted out on Monday morning, it was a ship that waited for the weather to improve because of its cargo. The ship was essentially a general cargo vessel. She was carrying two types of cargo from the United Kingdom to mainland USA. On deck, she had several large private yachts, and in the holds, she had paper rolls. Now, quite obviously, with the forecast winds over the weekend being in excess of 40 knots, the captain was reluctant to sail from his berth in Southampton. This was due to both types of cargo, both his deck cargo and the cargo that he had in his holds. I think it's quite obvious with the deck cargo as to why you wouldn't want a ship like that bouncing around in heavy weather. When yachts are carried on deck, they are lashed heavily to the hatches, but nonetheless, the spaces in between them can be quite small. If you enter heavy weather, regardless of how well the lashing is, parts of the yacht may start to move around, and damage may be occurred, both weather damage and damage from the movement of the ship. However, the yachts on this particular ship were well spaced apart. There was only about half a dozen of them over the length of the ship. The ship was 168 metres long, and therefore very, very big gaps in between the yachts. The yachts were heavily lashed down, and there weren't any really tall masts associated with sailing yachts, which I know are a problem with the ship in heavy weather. So I asked the captain why he was so worried about the weather, and his response was that although on deck he was unconcerned about the yachts, the paper in the holds was his main concern. So we discussed the cargo that he was carrying. He was carrying paper. He said most of it was what we would call drawing paper, rolls of drawing paper. Drawing paper is very, very rough surface paper that is taken across to the United States primarily for two reasons. Primarily for use as an artist's drawing, and secondly for use occasionally in paper printing presses. So if you look at the paper, the newspaper that's used, that is a very rough type of paper that can be quickly and easily printed upon, yet is not expensive to produce, and therefore when you are issuing and publishing large amounts of newspapers, you're not forking out a huge amount of money for the paper itself. This paper was in rolls. Now, rolls of paper are notoriously difficult to handle when they are loaded. This particular ship didn't have to have the paper loaded in through the hatches. They actually had great big lifts that went from deck down into the holds, and fundamentally these paper rolls were lifted with grabs that very carefully grabbed the paper roll with the paper roll actually upright, not on its side, placed it onto the lift. The lift would then descend down into the hold, and within the holds they also had these forklifts with these grabs on, and they would grab the paper and start to stack it up. Now, when they stack the paper, obviously they stack the paper so that they can try and lock the paper together within the holds. What we mean by that is that they put the paper in rows, and then the next row they start with what they call a locking tower. A locking tower is fundamentally where you put a row of coils that stop the row behind it from moving. If you imagine stacking pipes up in a bath, if you were to stack the pipes up along the bottom of the bath, and you pushed one end, the other end would lift up. And so therefore, if you have pipes on top of that to lock down the two sides of the pipe, then when you pushed on one side, you're unlikely to get a movement in the pipes. It's a little bit like looking at a cross section, if you like, of a beehive, and imagining the little holes in the honey as being tubes of paper or steel or something like that. Each one of those little honey cones locks in the other one, and it's a little bit like that on a ship. Just that with paper, this is upright, and this is something interesting I found talking to the captain about, because I would imagine the paper rolls being transported horizontally. Now, the reason they're transported upright is because if you transport paper rolls horizontally, in other words, the round part, if you like, is on the deck rather than the flat part being on the deck, then you can get compression damage. Compression damage is where, literally, a little bit like squashing a toilet roll, the weight of the paper above starts to squash the rolls at the bottom down. Now, as long as the paper has been properly packed, this doesn't generally damage it. But what it does do is start to put small folds in the paper. And it's these small folds that can cause problems when the paper gets to its destination, in particular if the paper is being used as a printing press, because to be fed through a printing press, the paper needs to be pretty much perfectly flat. So the captain explained to me that these paper rolls are stacked upright, so if you like, on the ends of the tube, on the flat side, stacked upright, pushed into the corners of the hold, and then locking towers put in order to stop the paper moving around. Now, I said to him, well, don't you lash the paper? Isn't there some way of holding those papers up? Because at the end of the day, you've got columns of paper standing up. And he said, no, we don't lash them. What we do is we put inflatable bags within the broken stowage. So where the holes are big enough to allow these paper coils to move around, they would put a bag in and inflate the bag with compressed air. This starts to lock the paper columns together and further stop them from moving. They do this all the way down to the end of the hold, and then the far end of the hold where they can't fit another row of these paper columns in, they will then yet again put some more inflatable bags. So that's the cargo secured. So I said, well, Captain, if your cargo is that secure, by the way you're describing, why are you so nervous about putting to sea with a little bit of roll? By the way, the GM of the vessel was only 0.8 metres, so a fairly small GM, which the captain was happy about because that made a very, very slow, long rolling period, and therefore, without that violent rolling period of a much bigger GM, much less chance that his yachts were going to start to break free from their lashings. By the way, all the way out of the Solent, that's what the crew were doing. The crew were running around on deck, checking every single lashing on those yachts on deck. Obviously, the captain quite concerned that those lashings were sufficient and tight. And as per his cargo securing manual, which he brought out very, very briefly to show me with regards to a particularly big yacht that I said had an amazing amount of lashings on, brought out his cargo securing manual, which had some standard size yachts within it, and showed the securings that should be put on the yacht. He also showed me an interesting document from the shipper, which showed the points that the yacht can be on the yacht that can be used for securing and those that cannot be used for securing. And obviously, as part of the careful carriage of that yacht, even though his cargo securing manual said X number of lashings, the captain had to be very careful that those lashings were on the bits of the yacht that the shipper had specifically identified as being securing points. Back to our paper cargo. So, Captain, if your paper cargo is so well secure, what's making you nervous about the heavy weather? And of course, one of the things that is really going to damage paper is, of course, the moisture content of the hold. Now, they have air dryers in the hold. The reason that they had air dryers in the hold is because the optimum travel temperature for paper is 20 degrees Celsius, plus or minus 5 degrees, and the relative humidity of somewhere between 60 and 70% relative humidity. So within each hold, he had hold dryers. These hold dryers, twofold. One, they would strip the moisture out of the air mass, and secondly, they would keep that temperature at that ambient transport point of 20 degrees Celsius or just around that level. Again, I asked, so Captain, if you have all of these things in your hold, why are you concerned about heavy weather? And his response to me was quite interesting. In order for the paper to be carried safely across to the States, it must be kept relatively warm. When it's loaded in Scandinavia, which is where he originally loaded it, it was loaded as very, very cold paper. Now, the trouble with very, very cold paper and going across to where he was going to the States, he was going down to Florida, very, very warm temperatures, high humidity in Florida. The trouble that he had was that he had to warm up the cargo. To gently warm the cargo means that he's got to have a certain amount of ventilation to allow his hold dryers to operate properly. If he puts to sea in heavy weather, then you get lots of spray and water on deck, and this can start to inadvertently adjust the relative humidity in the hold. In other words, it can make the air within the hold very, very humid indeed. Trouble with this is that because the paper was loaded in Scandinavia and is very, very cold, if you then have wet air going into a hold with a warming effect in order to try and keep the optimum travel temperature at 20 degrees Celsius, then what you essentially end up doing is you end up with a lot of warm, wet air in heavy weather above these coils of paper. Because the coils of paper themselves are still relatively cold, we have something called cargo sweat. Now, cargo sweat is caused by warm, wet air within a hold being cooled on the surface of the cargo because the cargo itself is loaded in much colder conditions. It's not that Scandinavia was particularly a lot colder than, let's say, the North Atlantic. It was because the introduction of moisture into the hold, even though the air inside the hold started off, if you like, as relatively cool when it entered, it got warmed up very, very quickly because of these dryers that they have within the hold to slowly warm the paper temperature up. If you don't warm the paper temperature up, by the time you get to Florida and you open your holds up, or you even just expose this paper to the warm, wet atmosphere of Florida, if it's still cold, then it will suffer almost immediate cargo sweat, and therefore the paper will be ruined because the cargo sweat will actually penetrate through the protective coating around the paper cargo. So the captain was reluctant to sail into heavy weather because he didn't want the spray affecting the relative humidity in the hold, which would mean that his drying process was adversely affected and he had the potential for there to be cargo sweat within the hold. In other words, the warm wet air would come in contact with the cold paper rolls and would start to condensate upon the cold paper rolls. I said, well, why, Captain, why don't you just turn up your hold dryer? You know, can you not deal with the amount of moisture that's coming in from the outside? He said, no, we can't do that because then we'll overheat the cargo. And if we overheat the cargo too quickly, the cargo itself starts to warm the air in the hold, and then we get something called ship sweat. So basically, if you heat the cargo up too much, the cargo then starts to warm the air above it. The air above it is then very, very warmed. Water is introduced through spray and what have you, and now the ship is colder than the cargo, so the moisture starts to form on the side of the ship. Because these paper rolls are, if you like, locked into the ship itself. They're actually in contact with the steel of the hold, and this means that if you heat the cargo up too much, this produces a warm, wet atmosphere within the hold, which causes the condensation not to form on the cargo as in cargo sweat, but to form on the cold steel of the hull and form what we know as ship sweat. Any part of the cargo that is in contact with the side of the ship will then become wet, and once again, as a paper product, this will ruin the paper and start to become less value, shall we say, to the receiver. Now, as with any cargo, it's really important for the captain and the chief officer to ensure that the bill of lading that comes with these paper rolls is accurate, and that the paper rolls themselves are inspected by the ship's crew prior to them being loaded on board, because they are as easily damaged during the loading and storage ashore as they can be damaged by the transportation on the ship itself. Indeed, the captain made the point that his hold control technology was a lot better than they sometimes have in some of the warehouses where the paper is stored prior to transportation. And so he's very, very careful when the paper is loaded that his crew and primarily his chief officer are watching to make sure that none of the paper that's arriving has been crushed, is damaged, or indeed appears to already be in a soaked condition. Finally, another interesting fact that he mentioned was that paper rolls can suffer from spontaneous combustion. I didn't realise this. I thought that spontaneous combustion was confined to other cargoes such as coal and those with with strange chemical properties. But no, self-heating and spontaneous combustion is a known problem for paper. Now, this is normally a result of the paper getting way too dry. So if you try and bring the relative humidity down below around 60%, the paper starts to dry out. When it dries out, one, it becomes brittle, and two, it starts to increase the risk of there being self-heating and spontaneous combustion. Now, it's recommended that the atmosphere within the hold is changed 6 times an hour. That's a recommendation for the carriage of paper, and it's that recommendation that helps to prevent the relative humidity dropping down low enough for spontaneous combustion to happen. But one of the downsides, of course, of changing the atmosphere 6 times an hour is that you are introducing plenty of oxygen into the hold, and therefore you may end up with self-heating if you allow the paper to get particularly dry. I found it interesting, this 6 times per hour changing of the atmosphere within the hold. Obviously on this captain's ship that was done through his air dryer, but some of you that are already studying your dangerous goods or are fully aware of the requirements for a ship to hold a dangerous goods document of compliance will be aware of the requirement for the ventilation of a hold to be sufficient enough to change the hold atmosphere 6 times an hour. The numbers are exactly the same. In other words, you could say that if you hold a dangerous goods document of compliance, you know that your ventilation systems are capable of exchanging the atmosphere enough times for the paper itself to be kept in good condition. So just to sort of précis what the captain and I discussed there, we discussed the fact that he didn't want to put to sea in very heavy weather, not because he was particularly concerned about his deck cargo of fairly new, fairly expensive yachts, but because he was more concerned about spray and seas coming in over the ship and splashing around by the holds and by ventilators and creating a moisture-rich atmosphere within his hold, which could make the paper wet, make it start to rot. He was very concerned about both ship and cargo sweat, and incredibly concerned that he had to slowly heat up the cold paper that was loaded in Scandinavia before it got to Florida, so that when it was discharged in Florida it didn't suddenly become wet in the warm, wet Florida atmosphere. All of these things added together to the captain's considerations as to whether or not it was safe for him to put to sea. So sometimes, as a master, when determining should I be putting to sea in heavy weather, sometimes it's not all about the movement of the ship. Sometimes it's not all about the securing of the cargo, or not all about the literally fundamental stability of the vessel. It's about hidden problems such as increasing the moisture content of the air in your holds, which may have a detrimental effect to the cargo that you are carrying. Just as a sideline from that, paper cargo suffers in this way, but exactly the same applies to steel cargoes when they are carried in holds, in that if you allow the same moisture problems to develop with steel cargoes, you can get heavy oxidization of steel cargoes during the passage, and of course oxidization of steel uses up oxygen within the atmosphere. So not only does this cause your steel pipes or your steel coils to start to rust and oxidize, but it quickly depletes the oxygen within the atmosphere of the hold, and this in itself can cause problems with regards to entering the hold at the end of the voyage. The hold should be treated as a dangerous space, the atmosphere tested, and full permit to work entry requirements implemented if you've had any kind of cargo within the hold that is subject to either oxidization or, in the case of paper, the rotting of paper due to moisture can also deplete oxygen from the atmosphere. So both paper and steel cargoes can cause a dangerous atmosphere within the hold. As a general rule, if you're ever going to enter a hold that has been closed for a long time, treat it as an enclosed space. Test the atmosphere first, ensure that it's safe to enter the hold before you commence cargo. And this was particularly important on the ship that I piloted, because as I explained at the beginning of the podcast, they had lifts to take the cargo down. They didn't open the hatches, therefore the holds themselves only had the ventilation that was provided by the vents, the fans, the dryers and the lifts. The holds themselves were not open fully to the atmosphere by opening the hatches, and therefore the potential for the atmosphere in the hold to be dangerous during the voyage and on arrival at the destination port is at a much greater and higher risk. Thank you all very much for listening to this latest podcast. I hope you found it interesting about the carriage of a particular cargo and a master's concerns for that cargo, and I look forward to welcoming you back to the next episode of the Maritime Education Podcast. My name's Barry Sadler. Have a great day, everyone.